Now, moving further for in the spherical mirrors, we have the next topic, that is sign conventions for spherical mirrors. Why this sign conventions is very important means, in order to draw the ray diagram for the spherical mirrors, that is both for concave and convex, you have to know exactly where is the object and how are the incident rays and reflecting rays for traveling, and where exactly is the image is formed. So for that reasons, at various positions of the object being placed and the image being formed, after this we will take up those rays diagrams. So for that, this sign convention is very important, and you can see here, for the explanation's sake I have taken a concave mirror, and this sign convention holds good for both for concave and convex mirrors. Now, for the explanation's sake, as I have explained, I have taken this concave mirror. Now, you can see the principal axis is always on the x-axis. You can see here, the first point is this principal axis is always horizontal. So it is not on the vertical, right? So principal axis, that is x dash, is always on the x-axis itself. So that is the first rule. And it is passing through the pole of the mirror. The pole of the mirror is also called as vertex or origin, and it is passing through the center of curvature also. So that is the first point. What is the first point? The principal axis is always represented on the x-axis, and that line will pass through the pole of the mirror or the origin and also the center of the curvature, which is extended on both the sides. Next, object is taken on left side of the mirror. You can see here, this is the object. Okay, AB is the object. It is always taken on the left side of the mirror. You can see here, this object is AB. It is always taken on the left side of the mirror. Second rule or second convention. Third one, all the distances measured parallel to the principal axis are measured from the pole. So, whatever the distances that you are measuring on the principal axis, that is parallel to principal axis, both up as well as down, should always be considered from the pole itself. That's why it is called as origin, which means now you want to find out the location of this object. You cannot measure from here the object to the pole. No, that is not it. From the pole towards the object you have to move. Means that's why pole is called as the origin. All the distances that you are measuring parallel to principal axis has to be measured from the pole. From the pole, not towards the pole, from the pole. Next point. Distances measured along the incident light is positive. Distances measured along the incident light. Distances measured along the incident light means incident ray. You can see it. From here incident ray will come for this concave mirror, right? So this incident ray is moving in this direction. So distances along this direction is considered to be positive. Okay, means if you are moving along the incident ray in the same direction, that distance should be positive. Why positive? Because it is the sign convention. Okay, it is the sign convention. I have not made the convention. It is not my rule. It is by convention itself. Now, distances against the incident light. Now you can see here, incident light is coming in this direction. You are measuring the you are measuring the distance in this direction. Both are opposite. It is incident ray is coming like this. You are measuring the distance like this. If both are opposite, then it should be taken as negative. Okay, so distances along the incident ray is positive, distances against the incident ray is negative. So that is the other convention. The next is height of the object measured above or upward above the principal axis is positive. You can see here the height of the object measured above the principal axis. See, this is principal axis. This height of the object I am measuring above, so it should be taken as positive. Similarly, the height of the object measured below the principal axis should be taken negative. So these are all the various sign conventions for the spherical mirrors. Hope you have understood.